Welcome to the ProSave tutorial series. In these tutorials, we will learn how to easily implement ProSave into your Unity game, and how ProSave can help you to not only save and load your game, but also to improve your game's architecture and make scene initialization easier. In this first video, we are going to discuss the best ways to structure and save game data with ProSave. I have opened a brand new Unity project, and if you would like to follow along, you should do so as well. If you are, import the ProSave package into your new project by going to Window, Package Manager, and searching for ProSave, selecting it, and importing it. Next, if you're using Unity 2021, Unity 2022, or a later version of Unity, go to Tools, Set up ProSave to complete the setup. If you're using an earlier version of Unity, skip this step. If you skip this step, ProSave will still work exactly the same way, but some icons might be different. Now that everything is set up, let's get started. First, we are going to discuss how to best organize data so that it is easily savable, loadable, and accessible. It is best practice to separate game data from the game objects that use that data. This is because we frequently want to destroy specific game object instances, but generally do not want to destroy the game data with those objects. For example, our player's character might have several data elements we would like to retain, such as health, level, strength, and intelligence. However, we may want to destroy the player character's game object when loading different scenes or when the player dies. When this happens, we probably do not want to delete the player character's data. There are several ways to effectively decouple game data from the objects that use it, but probably the easiest way is to create a class that implements a ProSave monobehavior. Create a new script, call it character data, open the script, and add using protools.saver at the top of the script. Next, set it to inherit from ProSave monobehavior. ProSave monobehavior is an abstract class that requires a type parameter. To inherit from ProSave monobehavior, you must write ProSave monobehavior less than sign, and then the name of the class, in this case character data, greater than sign. Classes that implement the ProSave monobehavior also require the implementation of a property called myInstance. To implement this correctly, add the following code line: public override character data myInstance equals greater than this. You will have to add this line of code every time you inherit from ProSave monobehavior, while obviously switching out character data for whatever you have named your new class. Now, return to the game scene and add an empty game object called GameDataObject and set its world position to 0, 0, 0, then attach a character data component to it. Let's examine the character data component in the inspector. ProSave monobehavior comes with several public fields built in. Let's go over them. Make singleton sets the component to be treated like a singleton. That means it will try to be the only example of itself in existence at any one time, and if another is created, the other will destroy itself immediately. This can be useful when managing data, as it means we don't have to worry about saving or loading data into incorrect locations. It also allows us to reference this instance easily. So long as your ProSave monobehavior class is set to be a singleton, you can reference it by simply writing the name of the class .data. So in this case, it would be character data.data. Leave make singleton as true. Destroy on load controls when and if this component's game object will be destroyed when loading a new scene. When set to do not destroy, it is never destroyed when scenes change, and when set to always, it behaves like a regular monobehavior, getting destroyed whenever a new scene loads. Destroy on specific loads allows you to specify which scenes it is to be destroyed on and which scenes it is to survive. You can specify which scenes you want the object to be destroyed on the Scene to Destroy on list below, where you write out the name of each scene you want this object to terminate on. Next, note the Add to Save toggle at the bottom. So long as this is set true, this object will have its data automatically added to the save when ProSaveTutVid1 is called. Obviously, we want to leave this set true. We will discuss the other fields shown in the inspector later in the tutorial. Now, let's add some data to character data that we might like to save. Let's add a string called character name. ProSave can save both public and private fields, but for this tutorial, we will make character name public. To signal to ProSave which fields we would like to save, we need to add to those fields the attribute SaveMe. SaveMe requires that we pass a field ID. Think of this as the label we give the field. It is critical that no two fields in the same class have the same field ID. You can, of course, make the field ID the same as the field name, but if you want to reduce the size of the save file, which can be a good thing, especially if you have to host the data, you may want to abbreviate the field ID down to a few letters. ProSaver can save primitive types, several Unity default types, custom classes, strings, lists, arrays, dictionaries, list of lists, arrays of arrays, and some other things. For a complete list of all the types ProSaver can save, visit the website address found in the README. Back in the Unity asset folder, create two new scripts. Call one character stat and the other ability. Open the character stat script, change it to an enum, and add the options strength, intelligence, agility, and health. Let's assume that these are the character stats for the game we are making. Now, go back into the character data script and add a character stats int dictionary field and name it character stats. And, like before, add the SaveMe attribute to it. Now we can save character stats. But our character stats dictionary is empty. We could just hardcode each character stat in, but if later in development we decide we want to add or remove character stats, we will have to modify the script. There is a better way to fill out this dictionary. Add using system to the top of the script under using protools.saver and create a new private method that returns void called add all stats to character stats. Within this method, add the following code. Character stats array all stats equals character stats array cast enum get values type of character stats. Skip a line. For each character stats stat in all stats, next line, character stats add stat 0. This will now automatically add all character stats included in the character stats enum to the game data character stats dictionary and set their stat value to a default value of 0. But we need to call this function somewhere. Let's add it to initialize. We will discuss the difference between initialize, late initialize, and complete scene prep in a later video. But for now, just know that initialize occurs before game data is loaded from its source and is a great opportunity to set up the default game state of your game. And, unlike awake, you can control the order of when specific initialize objects call initialize, and initialize implements anti-throttling techniques to make sure your game data does not freeze at the start of a new scene. To implement initialize, add the code public override void initialize. You can delete base.initialize if it automatically was added by your text editor. Base initialize is blank. Now, add in the following code. Add all stat to character stats. Skip a line. If ProSaver.initialize includes this, next line, ProSaver remove from initialize this. Skip a line. If include in initialize equals true, next line, include in initialize equals false. We add the additional lines of code because character data was set to do not destroy, which means it will not be destroyed when new scenes are loaded. But we only want initialize to be called once for character data, not at the start of every new game scene. which means we need to prevent it from subscribing to initialize after the first scene in which it is created. It is good practice in coding to encapsulate complexity and only expose what is necessary. For that reason, let's leave character stats private. But we do need to access and alter some data it contains. Let's add some accessor functions. Add a new public function called returnAllStats that returns an array of character stats and takes no parameters. Add another function named returnStatValue that returns an int and takes a character stat as a parameter. Finally, add two more functions, one called increaseStat and the other called decreaseStat, and have both take a character stat as a parameter and return void. Add using system.link to the top of the script under using system. Now, in the returnAllStats method, add the code return character stats.keys.toArray. In the return stat value method, add the following code: return character stats stat. In the increaseStat method, add the following code: character stats stat plus plus. In the decreaseStat method, add the following code: if character stats stat greater than 0, next line, character stats stat minus minus. Great! Now we can return all the stats in the game, return a specific stats value, increase a specific stats value by 1, and decrease a specific stats value by 1. Our character stats dictionary setup is complete. Now, open the ability script, change it to an enum, and add the options attack, dash, fireball, frost ray, healing touch, and summon skeleton. Let's assume these are the abilities a character can learn in the game we are making. It can sometimes be preferable to create subclasses within game data because it can improve code readability and encapsulate complexity. Create a new script and call it character abilities. Now open it, add using ProTools.saver at the top of the script, and delete the monobehavior implementation and the update and start functions. Add a private ability list and call it learned abilities. Give the list a save me attribute. Now, add an ability array, name it possible abilities. Add using system under using ProTools.saver. Next, create a parameterless constructor for the class and add the code line to it. Possible abilities equals ability array cast enum get values type of ability. Like with the dictionary, this will ensure that our possible abilities list is always complete, even if we change the enum later. Note also that all custom classes added to save must have a parameterless constructor to be savable. Next, let's add some functions. Add one function named returnAbilities, which returns an ability array and takes no parameters. Add another method named learnRandomAbility that returns void and takes no parameters. Add another method named hasAbility that returns a bool and takes an ability as a parameter. Finally, add one more method named unlearnAbility that returns void and takes an ability as a parameter. In the returnAbilities method, let's add the following code. Return learned abilities to array. This now returns an array of all abilities that have been learned. In learnRandomAbility method, let's add the following code. If learnedAbilities.count equals possible abilities.length, next line, return. Skip a line, int random index equals unityengine.random.range 0 possible abilities.length. Next line, ability random ability equals possible abilities random index. Skip a line, while has ability, random ability, inside curly bracket, random index equals unityengine.random.range 0 possible abilities dot length. Next line, random ability equals possible abilities random index. Outside of the while loop, learned abilities dot add random ability. Learn random ability now checks if all abilities have been learned, and if any hasn't, it selects one at random and adds it to the list of learned abilities. In the has ability method, add the following code. If learned abilities dot contains ability, next line, return true, next line, else, next line, return false. Has ability now checks if an ability has already been learned. In unlearn ability, add the code. If has ability, next line, learn abilities dot remove ability. Unlearn ability will now remove an ability from the learned abilities list if it is contained in the list. Let's add character abilities to character data. Go back to the character data script and create a character abilities field and name it character abilities. Add the save me attribute to it. Next, add return abilities, learned random abilities, has ability, and unlearn ability methods to game data, and have them return their respective character abilities methods. Great! Now we have a game data object with several different fields of different types. We have demonstrated how to create a game data object with ProSave monobehavior and how to specify which fields we want to include in the save by labeling them with the Save Me attribute. We have further demonstrated how to effectively save fields of different types, including simple objects such as strings, collections such as dictionaries and lists, and even more complex objects such as custom classes. We will continue with the tutorial in the next video.